Hi everyone, I'm Kristen Gasser from Team 11. We have decided to design instruments for the ASU alma mater song. Our defined problem definition statement is as follows. Create 4 working musical instruments within project requirements and constraints, capable of playing high, medium, and low range tones, and record a song using these instruments. Our defined project requirements are indicated on slide 4. The design criteria we have utilized are indicated on slide 5 of our presentation. The instrument I'm designing is a wind instrument within the high range. Design option 1 is detailed on slide 6, design option 2 is detailed on slide 7, and design option 3 is detailed on slide 8. Design option 3 is the final design selected for my instrument. This design is made from painted plastic straws, each cut to a length for a specific frequency of the song. The straws will be glued together to form one instrument and will fit nicely inside the 2 foot by 2 foot by 2 foot box.
Hi, I'm Wade Greenacre on Team 11. I'm constructing a percussion instrument for the low range part of the ASU alma mater song, which contains 9 different notes. On slide 9 I have my design option 1, a cantilever tubes design. This is made of 1/2-inch radius steel tubes mounted on a wood base and played with a rubber ball on a stick. This would be painted to match the other instruments in the band. The needed variables are included to calculate the length of each component, as well as the appropriate equations in MATLAB format. Option 2, my design option 2 is on slide 10, simply supported wood blocks. These are pine boards 2 inches wide and 1 inch thick, mounted on a wooden base. This would be played with a rubber ball on a stick. The variables and equations are also included. Slide 11 contains my design option 3, the cantilevered wood block instrument design. This is made out of the same material as option 2, 2 inch wide by 1 inch thick pine wood mounted on a wood base. Also played with a rubber ball on a wooden stick, and that includes the variables and equations as well. On slide 12, you'll see a table on the left that shows the 9 different frequencies needed for the low range part of this song, and the associated length of each component for each design option. The lowest frequency in the top row shows the maximum size of each design. The total length tells how much material will be needed for each design, and the cost is in 8-foot units able to be purchased based off Home Depot products and prices. Cost for the rubber balls on the end of the stick, the wood bases, and hardware are estimated to be less than $5. The decision matrix on the right simply shows if the design options meet the criteria, but doesn't show weighting. As you can see, option 1 far exceeds the $15 budget, and option 2 doesn't meet the size requirements. Option 3 meets all the criteria and is the selected design.
Another wind design, but we playing in a mid to low range, which is we're using PVC pipe with an open end, open top for bottom and top. Spray paint black. Use tape or glue to hold it together, was cost effective. We also have a mid-low range of option 3. Design option 3 was a pipe, aluminum pipe, which is still open end, open, bottom, top. And we also have one for option 2, which is bamboo, which is open end, open, bottom, top, brown, and it was very over the budget of our cost. So as far as all the options, we did our decision matrix, design 3 for each instrument, came to a conclusion to our final using design option 3 as determined by our decision matrix.
Hello, I'm Miriam Al-Halaby from Team 11. I have designed a string instrument that satisfies the medium-high range for the ASU alma mater song. Design options 1 and 2 are on slides 16 and 17, respectively, and my final design, design option 3, is on slide 18. From my calculations on slide 19, you can see that this design implements set string length, which results in different outputs of tension, which allow the instrument to play the medium-high range for our song. This design option uses readily available and cheap materials, while presenting the instrument in a very unique manner. The wire strings are tied lengthwise in a triangular hollow box and fastened with screws for easy tension adjustments. The instrument can be played by either plucking or with a pick.
Slide 20 shows the weighting and rating factors for each of the 5 criteria agreed upon by the group. Design option 3 of all the instruments was the highest rated and will be the instrument we built. It is interesting to note that the top 3 criteria remain high across all design options, but it was the cost and ease of assembly that made the difference.
To conclude, as a team, we decided, based on our decision matrix, that design option 3 was the best option. This option had the highest score and meets all project requirements, criteria, and is within the project constraints. Thank you from all of us at Team 11. Go Sun Devils!